Hi, good morning, everybody. Today we are going to be starting Unit 6, Exponents and Logs. So today we're going to be looking at Lesson A, taking a look at the review of exponent rules. So these are all things you've seen before in Algebra 2. And my happy little mnemonic device for remembering these exponent or power rules is mad spam. M to the A, D to the S, P to the M. And this mnemonic device is going to show you what your base operations are, multiplying, dividing, and powering up. And notice that I put parentheses around the P because that's one of the indicators of how you know you are powering up. And then the power operations are adding, subtracting, and multiplying. So depending on the operation that's going on between your bases, that's what operation you will do with your exponents. So our first rule, and you do not have to know the names of these, you just need to know how to evaluate with these properties, is the products of powers properties. So that's the M to the A, or multiplying the bases means we add the exponents. So if I have A to the M times A to the N, that is A to the M plus N. So in this box where we have all these rules, it's a little bit cumbersome with that all variable stuff. So I also have some examples off to the side here so you can really see what's going on as far as what we'll encounter out in the wild with these power rules. So x to the 7th times x squared. Our base operation is multiplying. That's the M part. So then what we will do with the powers to simplify is add them. So x to the 7th times x squared is x to the 9th. And if you thought about the expansion of this, you would have x times itself 7 times x times itself 2 more times. So x is being multiplied by itself a total of 9 times. So there's our first power rule. The next one is when there is division going on between our bases, we subtract our exponents, top minus bottom. So going over to our example, if we have x to the 5th over x to the 3rd, we identify our base operation as division. So that's the D to the S part of mad spam. So we're dividing, so we subtract our exponents. So that would give us x squared. So it's not that this is hard. We're just adding and subtracting and multiplying, but keeping straight when to do what is what makes this a little bit challenging. So my Algebra 2 students love this mad spam rule. I recommend writing it on your paper, practice writing what it looks like. Notice that there's no A in mad spam, so it's technically mad spam, but that's what we're going to be using for the power rules. So the P part, or powering up, is where things start to get a little bit more complicated. So if I have parentheses, we can assume that our base operation is we are powering up. So if I have x squared powered up to the 3rd power, or raised to the 3rd power, we multiply our base's exponent times the powering up exponent, which gives me x to the 6th. Where it starts to get tricky is when you have a monomial with an A and a B in it. Even though that's a monomial and it's one thing, it's actually 2 bases with 2 separate powers. So the little a has a power of 1, the b has a power of 1. So when I power that up, I have to distribute that power of m to both of those. Same goes if I have a fraction getting powered up, I have to distribute that power to every single base's power in that fraction. Our next property, this is kind of all inclusive in mad spam. This is just how do we deal with negative exponents. If I have a to the negative m, I always say that we think of these negative powers as bad attitudes, and to resolve the bad attitudes, we send those bases with their negative powers to the other part of the fraction. So if I have a to the negative m, we resolve it by sending it downstairs to the denominator, so then it becomes 1 over a to the m. If I have the flip of this, if I have a bad attitude in the downstairs of a fraction, then to resolve it, we are going to send it to the upstairs, and it becomes a to the positive m on the top. So that's going to be one of our simplifying rules, is you never actually want to leave negative powers. So that's going to be part of resolving with our fraction. So if I distribute this one, the negative a goes to the x, the negative a goes to the y. So both of those get that negative a power. So we would have to switch both of those to resolve those negative exponents. Don't lose your head with these negative powers. If I have negative 2/3, that is not 1 over 2 times 3. Negative fractions just stay negative fractions.